We are going to look at interfacing a bn-880 GPS module with a Raspberry Pi 4. The bn-880 includes a 5883 3-axis magnetometer that is used as a compass by using the X and Y magnetic field components to determine the direction it's pointing. The Z-axis magnetic field can give a rough idea of the tilt angle of the module. Like the bn-220, the bn-880 GPS uses a serial interface. The 5883 magnetometer has an I2C interface. I couldn't find a detailed datasheet for the bn-880. However, the GPS for the bn-220 uses the same M8030KT chip as the bn-880, so the serial message structures are the same. Honeywell's datasheet for its HMC 5883L chip gives detailed instructions on write and reading from the chip. It uses two 8-bit registers to form the 16-bit data. In this example, a C++ program is written within the Qt IDE to utilize Qt to program a simple GUI for the program. Qt has both a GNU license version and commercial license versions. Here, the GNU license version is used. The program is written and run on a Raspberry Pi 4. Instructions for installing the GNU version of Qt are available on their website www.qt.io. Qt programs are written in Creator. Assistant gives descriptions of the Qt library of functions. The Qt library gives a large number of functions to augment the C++ STL library to make programming easier. Qt also works with Python, Java, XML. Here, we use the standard Qt widget structure with a project file giving the other libraries being utilized. The C++ header file gives list the header files being included in the program as well as the defined classes. The main window class describes functionality for the widget and use QPaint to draw the compass dial and hand as well as updating the values displayed. Since there are two sensors in the bn-880 module, a thread structure is used so the data is accessed in parallel and continuously. One thread reads data from the GPS while a second thread reads data from the 5883 magnetometer. Each sensor has a class to interface with its thread. The forms file contains the GUI designed graphically. The source code for the different classes is in the main Windows CPP file. The main CPP file contains the code to run the program. The MyGPS 880 class has a function to initialize the GPS communication by opening the serial port connection and initializing wiring Pi, a library of convenient function for using the Raspberry Pi PO. The read GPS function is used to read data from the GPS serial port and get the latitude, longitude, altitude, and time data using the different message structures available. QString variables and Qt functions are used to simplify the procedure. The data is read one character at a time and the different message structure are identified by the message ID. The GPS coordinates can be sent to Google Maps to plot the location and/or directions to a destination with the system command, which open Google Chromium and sends the appropriate URL. A timeout is given in the call so the web browser closes after a specified amount of time. Since I am shy, randomly generated coordinates are utilized for this demonstration instead of the data read from the GPS. The 5883 class is used to initialize the magnetometer and read its data over the I2C interface. Wiring Pi functions are used to write and read from the 5883 registers. Data is read from two 8-bit registers to obtain the 16-bit value. The X and Y data are used to calculate the direction angle which is used to position the compass hand. The Z-axis data could be used to correct the X and Y data when the magnetometer is tilted. Rotating the 880 module causes the compass hand to rotate real-time. The End button deletes the GUI, causing a sudden close of the program.